Hello guys, welcome to this tutorial session on thermodynamic properties. So here we will try to solve some objective questions of this chapter. I hope this session will make your concept clearer, right? So I am Dr. Himanshu Singh. Let's try to solve some questions, some fundamental questions. Okay, now the question number one. So guys, you can pause this video, first solve question number 1 2 3, then just see the explanation, right? So let's read this question. A thermodynamic uh, is defined as a quantity of matter or a region in space upon which attention is concentrated in an analysis of a problem. So we have understood that we have a system and we have a surrounding, right? And in between system and surrounding we have this boundary, right? So system is what in which attention is concentrated, and system plus surrounding is called universe. So the answer will be A part. Everything, now question number 2, everything external to a system is called, so everything external to the system will be what surrounding, or you can say environment, right? So answer will be A. Now question number 3, in a closed system, so what we understand by a closed system? So we have discussed in our class that in closed system, quantity mass remains same and their identity remains same, identity of those particles which are inside the uh, system, that identity will remain same, and there will be uh, energy interaction between the surrounding, right? Let's try to understand. Let's check option A. Mass and heat can cross the boundary of a system. Heat can cross, but I think mass will be same, mass will be constant inside the system. Only mass can, so this will be wrong. Only mass can cross the boundary. No, mass will remain constant, so this will be wrong. Only heat can cross the boundary. Yes, heat and work both can cross. It means energy can enter or energy can go outside, correct? So I think option C will be the perfect one. Neither heat nor mass can cross the boundary. So this is for which system? This will be for isolated, correct? So answer is C part. Let's solve more questions. Now just pause the video, first solve question number 4, question number 5, question number 6, right? Then just see my explanation. Air cooler can be considered as, let's see, open, close, आइसोलेटेड, न एयर कूलर में क्या होता है यार? सो एक कूलर होता है एंड हियर वी हैव अ फैन, यहाँ से हवा बाहर जाती है और यहाँ से हवा इनसाइड जाती है. सो हियर व्हाट इज़ हैपनिंग, energy is coming inside the system, energy is going outside the system, and also some that mass of the system, suppose we have water inside the air cooler, right? So mass of the water will evaporate as time passes. So mass का भी flow through the boundary and energy का भी flow through the boundary. So it will be what? Open system. Let's check. Properties which do not depend on the mass is called, property which do not depend on the mass is called, so we have discussed in the class that some property, we have taken the example of pizza, right? Pizza, and we have taken the example of tea. अगर मैं एक केटल में मैं चाय उबालूं और उसे मैं 5 लोगों को उस कप में मैं चाय दे दूं, सो द टेम्परेचर ऑफ टी इन ईच कप विल बी सेम एज द टेम्परेचर ऑफ द केटल. So temperature does not depend on the mass of the system, right? uh, so here, which do not depend on the mass of the system, it will be what? Intensive properties. Extensive property is one which is extensive property which depend on the mass, which depend on the mass. So I told one concept to remember: intensive. Intensive is what? Independent of mass. Independent of intensive properties are independent of mass. Okay, so now let's go to next question. Which of the following is not an extensive property? Which of the following is not an extensive property? So we have discussed that volume. So we have discussed that uh, volume, enthalpy, entropy, these are extensive properties. These are extensive property. But when we divide these quantities by mass, then it becomes enthalpy. This E stand here for enthalpy. S divided by M, this becomes what? Specific volume. This becomes specific enthalpy. This becomes specific entropy, right? So when we divide our extensive property by mass, then this quantity will become intensive property. I hope it is clear. So answer will be what? Not an extensive property. Enthalpy is extensive, this is extensive, volume is extensive, entropy is extensive, specific enthalpy, this is intensive. Which of the following is an extensive property? Extensive property, okay, let's check. Which of the following is an extensive property? Enthalpy is extensive. Pressure is what? Intensive. Density is intensive. Temperature is what? Intensive, right? So why I hope this is clear. Pressure, temperature, density, these are intensive property because these property do not depend on the mass of the system. And okay, so for density, if we see, the formula of density is what? Mass by volume. If we take a system of mass m and volume v, and if we divide this system by two partition, एक का मास हो जाएगा यहाँ पे m/2, this will be m/2, वॉल्यूम विल बी v/2 एंड वॉल्यूम विल बी v/2. अच्छा यार, यहाँ से डेंसिटी में निकालूंगा कितना आएगा? इट विल बी m/v. एंड इस सिस्टम के लिए अगर मैं डेंसिटी इस सेक्शन का निकालूंगा, दिस विल बी व्हाट? m/2 upon v/2. it will be what? m/v. so you can see that density initial भी यहाँ इस सिस्टम की डेंसिटी कितनी थी? m/v. फाइनल पार्टीशन करने के बाद डेंसिटी कितनी आई? m/v. करेक्ट. सो दिस density does not depend on the mass. Density is independent of the mass. So I hope these concepts are clear. Now come to this question. Which of the following is an intensive property? Again, so this is volume is extensive, specific volume is intensive, enthalpy is extensive, and mass is extensive. Heat and work are intensive properties, extensive properties, independent properties. यार कंसेप्ट यहाँ पे ये है कि हीट एंड वर्क, इट इज़ नाइदर it is neither extensive property nor इंटेंसिव प्रॉपर्टी। कंसेप्ट ये है कि हीट एंड वर्क इज़ नॉट अ प्रॉपर्टी, हीट एंड वर्क इज़ नॉट अ प्रॉपर्टी। वी विल डिस्कस दिस थिंग इन द क्लास। वी हैव गिवन वन असाइनमेंट ऑफ कि प्रॉपर्टी रहने के लिए एक डिफरेंशियल इक्वेशन फॉलो करती हैं। सो वी विल डिस्कस दिस कंसेप्ट इन द क्लास very clearly. A system is said to be in thermodynamic equilibrium. A system is said to be in so heat and work are this, none of these. Heat and work is not a property, right? So heat and work is defined in a transit state, correct? So that's why it is not a property. A system is said to be in thermodynamic equilibrium. Question number 11. A system is said to be in thermodynamic equilibrium when, let's see, there is no work transfer, there is no heat transfer, internal energy of a system is zero, no change in macroscopic property is registered. So thermodynamic equilibrium का concept ये रहता है कि suppose we have a system और इस system पे if I measure temperature at this point, यहाँ पे temperature कितना आ रहा है T, इफ़ आई मेज़र द टेम्परेचर एट दिस पॉइंट, यहाँ पे भी टेम्परेचर T आना चाहिए, यहाँ पे भी T आना चाहिए, यहाँ पे भी T एंड यहाँ पर भी T। हर एक स्पेस पे टेम्परेचर यूनिट शुड बी सीन, तभी ये थर्मोडायनेमिक इक्विलिब्रियम में होगा, राइट? इन इट विल बी इन थर्मल इक्विलिब्रियम गाइस, ओके, इट विल बी इन थर्मल इक्विलिब्रियम. For thermodynamic equilibrium, it should satisfy all the thermodynamic, mechanical, chemical, all property it should satisfy, right? So there is no work transfer. इसका कोई इफेक्ट नहीं होने वाला यार, इसका भी कोई इफेक्ट नहीं होने वाला. Internally of the system is zero. It is also not correct. No change in microscopic property is registered. So let's see, यहाँ पे टेम्परेचर, अगर ये थर्मल इक्विलिब्रियम की बात कर रहा है, then temperature will not vary. If it is in mechanical equilibrium, so this body will be all the forces will be constant and there will be the no pressure gradient in the system, right? If it is in thermal equilibrium, then there will be no dt by dx, right? And dt by dx will be zero. And if it is in mechanical equilibrium, dp by dx, there will be no pressure gradient. And if it is in chemical equilibrium, some potential will be, it will be constant with xyt, right? So this is the main concept. So no change in microscopic property is registered. So I hope it will be clear up to this point. Let's come to question number 12. A body would be in thermodynamic equilibrium when it is in, okay, let's see. So as I have already discussed, thermodynamic equilibrium के लिए क्या क्या चाहिए. So I want dt by dx should be zero. Chemical equilibrium, d mu by some parameter dxi, that should be zero. For mechanical equilibrium, dp by dx, there should be no pressure gradient in the system, this should be zero. Then only system will be in state of thermodynamic equilibrium, right? So answer will be D. Now come to question number 13. Question number 13, okay, so intensive properties, extensive path function, okay. So intensive property कौन कौन सी हैं यार? This will be what, let's see, ये यहाँ पे specific volume. Extensive property is what? Volume. Path function is what? Heat and work. Heat and work, these two mode of energy transfer, this is not a property, this is a path function. Isolated system will be this thermal flask. So next come to question number 14. A process which is a locus of all the equilibrium points is called, So let's try to understand क्या कहना चाह रहा है ये. So we have discussed on PV curve, a process which is a locus of all equilibrium point is called. So we have a PV axis, and here suppose we have a system. We have a system with piston and cylinder arrangement. So I hope you have already covered this concept. So this is cylinder, this is piston, this is cylinder, and here we have kept very small masses. और हम लोग क्या करेंगे यार, यहाँ पे धीरे धीरे मास को रिमूव करेंगे इस सरफेस से. देन व्हाट विल बी हैपन, volume of the system, volume of the cylinder will increase, volume of the cylinder will increase from state 1 to state 2, करेक्ट. तो इसमें इस मोमेंट पे इफ़ वी हैव अ सेंसर एंड इट इज़ मेजरिंग द प्रेशर एंड टेम्परेचर ऑफ द गैस इनसाइड द सिलेंडर, सो हर एक मोमेंट पे आई विल गेट द प्रेशर वैल्यू, करेक्ट. आई विल गेट द प्रेशर वैल्यू एंड हर एक मोमेंट पे आई विल गेट द प्रेशर वैल्यू, राइट. हर एक मोमेंट पे आई विल गेट द प्रेशर वैल्यू. देन it will be a straight line, correct, it will be a straight line. So it will be from 1 से 2. this is the same, I just repeated the process. और रियल प्रोसेस जब रहते हैं, रियल प्रोसेस में क्या होता है यार, सो वी हैव पीवी डायग्राम. रियल प्रोसेस में क्या होगा, इफ़ इट इज़ कमिंग फ्रॉम स्टेट 1 टू स्टेट 2, सो it will be with some, it will be not इन्फाइनेटिज्मली स्मॉल, धीरे धीरे नहीं होगा, थोड़ा फास्ट में होगा, है ना. सो मुझे प्रेशर की वैल्यू इस पॉइंट पे मिलेगी, इस पॉइंट पे मिलेगी, इस पॉइंट पे मिलेगी, इस पॉइंट पे मिलेगी, करेक्ट. सो दीज आर द रियल प्रोसेसेस, इट डिनोटेड बाय डॉट लाइन, राइट. तो 14 का आंसर हो जाएगा द प्रोसेस विच इज़ लोकस ऑफ ऑल इक्विलिब्रियम पॉइंट्स. दिस विल बी व्हाट, क्वासी स्टैटिक प्रोसेस. जस्ट रिमेंबर वन कंसेप्ट, दैट देयर इज़ अ कन्फ्यूजन बिटवीन व्हाट इज़ क्वासी स्टैटिक एंड रिवर्सिबल प्रोसेस. इस एक ही कंसेप्ट याद रखिएगा, रिवर्सिबल प्रोसेस इक्वल्स टू क्वासी स्टैटिक प्रोसेस प्लस फ्रिक्शनलेस प्रोसेस. सो दिस इज द कंसेप्ट. सो आंसर विल बी सी. लेट्स कम टू नेक्स्ट क्वेश्चन. Which of the following is not a property? Which of the following is not a property? I have already discussed. Volume is the what? Extensive property. Temperature is intensive. Pressure is intensive. And heat is not a property. Heat is not a property. Answer will be A part. The energy 16. The energy is an X property. And the temperature is Y property. The word X and Y respectively are. So let's try to think. Energy is extensive property, so temperature is Y property. Temperature तो अच्छा, temperature is intensive property. Temperature is what? Intensive property. This is clear. And it is talking about energy, so it can be. अच्छा, यहाँ पे हीट एंड वर्क की बात नहीं कर रहा है, बिकॉज इट इज़ सेइंग कि दिस इज़ ए प्रॉपर्टी. हीट एंड वर्क आर नॉट ए प्रॉपर्टी, राइट. सो एनर्जी तो यहाँ पे वी कैन अज्यूम दैट इट इज़ टॉकिंग फॉर इंथैल्पी. इंथैल्पी कौन सी प्रॉपर्टी हो जाएगी यार, इट विल बी व्हाट, एक्सटेंसिव. आई थिंक आंसर विल बी क्या हो जाएगा, डी पार्ट. विच ऑफ द फॉलोइंग इज़ नॉट ए प्रॉपर्टी. So I think heat is not a property. We have already discussed these things. So guys, let's do this quickly. An isolated system, good, let's try to understand isolated system. So isolated system, how we define that, we have a piston cylinder arrangement. It does not interact with the surrounding. There is no energy transfer, energy transfer no, and mass transfer no. So always reaches the thermodynamic equilibrium. Okay, never reaches the thermodynamic equilibrium अब जैसे मैंने क्या किया, मैं एक थर्मोफ्लास्क कप लिया और उसमें मैंने इस कंटेनर में मैंने गरम गरम चाय फिल कर दिया, करेक्ट। लेट्स सी, चाय का टेम्परेचर 60 डिग्री सेल्सियस है, राइट। अगर मैं इसको मॉर्निंग में अराउंड 10 AM मैंने फ्लास्क में इसके अंदर रख दिया है, सो क्या होगा यार, रात में अगर मैं 9 AM मॉर्निंग पे मैंने टेम्परेचर मेज़र किया, इट केम अप टू 60 डिग्री सेल्सियस। और मैंने क्या किया, फिर 9 PM रात में मेज़र किया, टेम्परेचर कितना आएगा। सो आई थिंक ये क्लियर है कि दिस टेम्परेचर will be less than this temperature, right? So let's see, never reaches the thermodynamic equilibrium. अगर environment का temperature let's we take 30 degree Celsius, right? So always reaches the thermodynamic equilibrium यार, it will not possible. Never reaches the thermodynamic equilibrium, ये भी नहीं होगा कि 60 डिग्री सेल्सियस 30 तक नहीं आ पाएगा। may or may not reaches the thermodynamic equilibrium depending on the surrounding, correct? So अगर if this flask is kept in a 60 degree environment, तो इसका इक्विलिब्रियम नहीं मेंटेन होने वाला। व्हाट डू यू अंडरस्टैंड बाय थर्मोडायनामिक इक्विलिब्रियम, दैट इट इज़ टॉकिंग हियर, इट इज़ टॉकिंग फॉर थर्मल इक्विलिब्रियम, राइट। सो I think answer will be always reaches only mechanical and thermal equilibrium, so not this. So answer will be this, that after some time of interval this system will may or may not get reach the thermodynamic equilibrium with the surrounding. Okay, so I hope this is clear. So match the list, intensive property ये हो गए हैं। I think आंसर कितना आएगा इसका, intensive, okay let's try to do this. So intensive क्या हो जाएगा, this, specific volume this, okay, extensive property is mass, extensive property is volume, right? So answer will be A. Now which of the following is the basis of temperature measurement? The zeroth law of thermodynamics, this is the basis of temperature measurement. We will discuss this in detail in the class. Which of the following thermodynamic property is used in thermocouple? Which of the properties thermocouple is used in thermocouple? Okay, so in thermocouple क्या होता है, टेम्परेचर डिफरेंस रहता है, एंड फ्रॉम टेम्परेचर डिफरेंट वी मेज़र द EMF in the sample, we measure the voltage, so it is what EMF. Volume is used as a thermometric property in which of the following thermometer? So let's see, constant gas thermometer, constant pressure gas thermometer, this is the answer. Okay, so this question number 23, Fahrenheit scale shows this. So here guys we have a standard formula, C by 5. So here we have to convert centigrade scale to Fahrenheit. The relation is related by this, C by 5 equals to F minus 32 upon 9. So you have to put the value of F here as a 98.6, 98.6, and you just calculate the C value. So C value after calculation, I think you have to calculate and you will get the answer here. Okay, so 23rd is clear. 24th, the zeroth law of thermodynamics gives the concept of it gives only the concept of temperature. Which of the following is not a properly matched? Which of the following is not a properly matched? Okay, let's try to understand. Intensive property, yes, temperature is intensive property. Extensive property, heat is intensive or extensive? No bhaiya, heat is not a property. Heat, I repeat again, heat and work not a property. Okay, a path function does not depend on the end condition only. So path function is depend on the process, it does not depend on the end conditions, right? Quasi-static process is locus of equilibrium point. This is also, this statement is correct, this statement is correct, this statement is correct, and this is the not properly matched, so this is not properly matched, this is wrong. So let's try to, okay, nice. So we have some conceptual questions more. A sealed thermos of hot coffee in space, no surrounding, is an example of. So we have already discussed कि एक कप कप के अंदर चाय है. This will be what? Isolated system. If question number 2, if you split a pizza in half, which property divides into two equal parts? With two equal parts, so we have discussed these things in the class, that it will be divided in, so it is divided in the half, so m1, so complete mass is m, so it will be how much? M by 2, m by 2, it depends on the mass, right? So answer will be what? B. Why can't you feel entropy directly? Why can't you feel entropy directly, right? So actually entropy is measurement of randomness at statistical point of view. We can't measure directly, right? So there are indirect method to measure the entropy value, so it is hidden property requiring math. So this is the concept here. Only ghost can sense? No bro. A balloon deflating over time is not in equilibrium. A balloon deflating over time is not in equilibrium. Okay. सो एक वॉल्यूम है, एक बैलून है और उसका शेप स्टार्टिंग में ऐसे है, एंड आफ्टर सम टाइम इट शेप इज श्रिंक टू लाइक दिस. सो व्हाट वी आर ऑब्जर्विंग हियर, इनिशियल इसका वॉल्यूम इतना था, अभी क्या हो गया है? दिस वॉल्यूम इज चेंज्ड. प्रेशर यार यूनिफॉर्म नहीं रहेगा, सो वॉल्यूम विल चेंज हियर, इट विल नॉट बी इन इक्विलिब्रियम, वॉल्यूम इज गोइंग टू चेंज. आंसर विल बी बी. Question number 5, mixing 25 degree Celsius water with 25 degree Celsius water results in. अच्छा यहाँ पे if some people may have doubt कि यार 25 डिग्री सेल्सियस का वाटर है, मैंने 25 में ऐड कर दिया, तो हियर टेम्परेचर इज़ T, हियर टेम्परेचर इज़ T, तो दोनों का टेम्परेचर क्या हो जाएगा? 2T. सो दिस इज़ नॉट करेक्ट, बिकॉज temperature is not intensive property, we can't measure this. So then how we will calculate the temperature of the fluid, temperature of the resulting solution? So there will be the what, if water temperature is 50 degrees Celsius and another water temperature is, let's take this 20 degrees Celsius, so we have to balance energy, then from there we will get the temperature values. Okay, so now let's come to another question. I think यहाँ पे 5 का आंसर will be B. It will be 25 degrees Celsius water. Now come to question number 6. What is the key differences between closed and isolated system? So question number 6, what is the key difference between closed system and isolated system? Right, now let's try to understand. Answer A, let's check A. Mass can transfer in both. No. Isolated system allow energy transfer. No. Closed system allow energy transfer. Yes. Only isolated system have boundaries. No. So isolated में क्या concept था? We have already discussed. In isolated, no mass, no energy transfer. So this is the concept. And in closed system, identity will be mass, identity of the mass will be remain constant. ये चीज़ ध्यान रखिएगा, मास का वेट सेम, मतलब वेट मास सेम रहेगा, and the identity of that mass particle will be remain same in that closed system. Question number 7, dead state occurs when so a system explodes. No. So जैसे मैंने ये चाय का एग्जांपल दिया था, एक कप है, इट इज़ चाय इसमें रखी है, एंड इट इज़ ओपन टू इन्वायरमेंट. ओके, इन्वायरमेंट का टेम्परेचर मान लो 25 डिग्री सेल्सियस है, एंड चाय का टेम्परेचर स्टार्टिंग में 50 डिग्री सेल्सियस है, एंड आफ्टर सम टाइम दिस टी कम इन द temperature of 25 degree Celsius, so it will be what, it is defined as a dead state, that there is now no more change in the system property will be observed. So this will be at the dead state. So I think answer will be B. Answer will be B. System equal to surrounding, there will be no driving force. Okay, let's try to understand question number 8. Which property is always intensive? Which property is always intensive? तो यार ये तो एक्सटेंसिव होगी, वॉल्यूम इज एक्सटेंसिव, स्पेसिफिक वॉल्यूम इज इंटेंसिव, मास इज एक्सटेंसिव. So let's check another. Why does a fridge never reach equilibrium with your kitchen? Why does a fridge never reach equilibrium with your kitchen? I think it is no, it is not isolated system. It is intensive property. Its intensive property as uniform, no. It is in dead state, no. So answer will be what, it constantly pump heat out. If you inflate a balloon, which property becomes non-uniform temporarily, right? So which property becomes non-uniform temporarily? So guys, concept ये है. So here we have initial form of balloon, and after some time balloon फूलने पे ऐसा हो जाता है, right? So pressure will be increasing from this state 1 to state 2. There will be some dp by dx pressure gradient will exist. It will not be equals to 0, correct? So that non-uniform temporally, which property become non-uniform temporally? So this will be what, pressure. बिकॉज ऑफ प्रेशर डिफरेंस ये बैलून फूलेगा, अदरवाइज इसका फूलना मुश्किल है, राइट? सो डी पी बाई डी एक्स विल नॉट बी इक्वल टू 0 हियर. ओके, गुड. So what is the temperature difference of 10 on Celsius scale corresponds to a Fahrenheit scale? So the concept is very simple. We have to use formula C by 5 equals to F minus 32 by 9. So by solving this, I think answer C will be the correct answer. Okay, so we have some more brainstorming. Let's see. Open system is the one in which I think we have already discussed, so answer will be C. Which of the following is a point function? So temperature is a point function, yes. Pressure is a point function, yes. Internal energy is a point function, depend on the temperature. Power is not a point function. Power depend on work, and work is a path function. So answer will be what, A, B, C. Which of the following is an intensive property of the thermodynamic system? So you can explore this. Answer is B. The basic temperature measurement is what, zeroth law of thermodynamics. The absolute zero pressure will be, just think, the molecular momentum of the system becomes 0. So how pressure is generated inside a system? So here we have system and here we have different molecules, right? और हम लोगों ने यहाँ पे एक सेंसर लगा के रखा है, एक सेंसर इस पॉइंट पे, एक सेंसर इस पॉइंट पे, एक सेंसर इस पॉइंट पे. सो हाउ वी आर गोइंग टू मेजर द प्रेशर? सो ये जितने मॉलिक्यूल्स हैं, इफ़ टेम्परेचर इट इज़ गेटिंग हीट फ्रॉम द आउटसाइड, ये सारे इधर भड़ भिड़ेंगे यहाँ पे, राइट? इट्स बिकॉज ऑफ मोमेंटम चेंज, इट विल अप्लाई सम प्रेशर ऑन द बाउंड्री. सो फ्रॉम देयर वी विल गेट द मेजरमेंट ऑफ प्रेशर, एंड इफ़ molecular momentum it becomes 0, then we will get absolute pressure. So this is the concept. I think answer A will be the right answer. So question number 5. Question number 6. The standard fixed point for a thermometry is 6th card. For a thermometry, yes, we will explore this. Triple point of the water is the fixed point here. A system comprising a single phase is called, we have already discussed, homogeneous system, a mixture of air and liquid air. We have discussed in a class, so I think it is not a pure substance. This concept, there's a conceptual one student has asked, so we have discussed this in detail in the class. So 8th B. Then 9th, when mean free path of molecules of a gas approaches the order of magnitude of the dimension of the vessel, which concept of the following loses its validity? It is already explained. Continuum concept will not exist there. Most of the real processes are for quasi-static, non-quasi-static activity. This will be non-quasi-static. And how we define quasi-static and reversible process? Again, I am writing here, reversible process is equals to quasi-static process plus frictionless. This is the condition of reversible process, frictionless process. Question number 11, number of independent thermodynamic variables which are required to determine the thermodynamic state of liquid water in equilibrium with saturated steam. So we have this formula that P equals to C. Then what we have discussed, PC के सामने दो फंटूस बैठे हुए हैं. So here if we see, so here we have component 1, that H2O, and we have phases 2. So now put the value of these, so we will get F plus P की value है 2, C की value है 1, so it will be 2. F will be what? How much? F will be 1. F will be 1. Answer will be B. Select the correct statement among the following. Select the correct statement among the following. So the working principle of thermocouple is Peltier. No, it is Seebeck effect. The thermocouple consists of two wire legs made of same metal. No, different metal. Thermopile is a series connection of thermocouples, so it is just standard concept, guys. The resistance of a platinum wire at a ice point is 5 ohm and steam point is 5.39. When the thermometer is inserted in a hot bath, the resistance of a platinum wire is this. That bath temperature is nearly, so here just you have to use at steam point. Okay, so let's take this steam point equals to what? Ice point into 1 plus alpha delta T. So from here I think you can calculate the value of the bath temperature increase. Just put in this formula, I think you will get the answer. Answer will be around 203. A part, which of the following are the example of irreversible process? Which is the example of irreversible process, right? So here let's see, isothermal expansion. It is around reversible. And electrolysis is, it can be taken as irreversible process. Plastic deformation is also irreversible process. Combustion of any material, any substance is also irreversible process. Electrolysis, in some books it describes as a reversible process, but if we measure all the physical and chemical changes during electrolysis, so this will be irreversible process. I hope, guys, I think this is completed here. So I hope this explanation will help you in reinforcing your thoughts and making clear your concept more clearer, right? Okay, thank you so much, guys, for watching this video.